All right, this video is to help you get started on your implicit differentiation bookwork. And I'm going to do a few questions. I did a lot of these in class to help you get started on your homework assignment. So we're going to start right with number one. And number one is xy plus 2x plus 3x squared equals 4. So what this question wants you to do is to actually do the differentiation implicitly and then do it explicitly and see if they match or if you get the same solution. So this one's easy to kind of do. It's a good start. I notice right here, this is the product rule. So this is my f and g. So let's set it up here. My f is x, my f prime is dx. My g is y, my g prime is dy. You kind of get good at this one because you'll do it so many times. So I got f prime g, so I got y dx plus x dy, which is f g prime. So that takes care of my first term, plus 2 dx plus 6x dx equals, and the derivative of 4 is 0. So what we're going to do now is go through, because we're solving for dy dx, let's go through and divide through by dx. And you'll notice there's a lot of dx's here. And so this is going to cancel, make a 1, make a 1. So I'm basically going to leave x dy dx here on the left. And then I'm going to move everything over to the right. And when I do, it's going to change all their signs. Okay, so I'm going to have a negative y, a negative 2, and a minus 6x. And then I'm going to divide by x. So I have dy over dx, or my derivative, is negative y minus 2 minus 6x all over x. Okay, so I did that. I did it implicitly, and that's my answer. So I want you to notice that, because now they said, okay, do this one explicitly. So we're going to take our original and basically isolate the y first and then take the derivative. So let's start down here. So this is the B part of this question. So I'm going to take my original. So I have xy plus 2x plus 3x squared equals 4. And then I'm going to isolate the y so I can do this differentiation explicitly. So I have xy equals 4 minus 2x minus 3x squared. So I just kind of moved them all over to the other side. And you can rewrite in a different order. And then I'm going to divide through by x. So I have, let me undo what I just did there. So if I divide through by x, I'm going to have y equals, and I'm just kind of rewriting this as I go. So it's going to be a negative 3x, okay, minus 2. Then it's going to be plus 4 divided by x, but I'm going to write it as x to the negative 1 because I know I got to take the derivative. So I didn't do the derivative, I just isolated my y. Now I'm going to do the derivative f explicitly. Now we usually use y prime, but we're going to use dy dx is going to equal negative 3. Okay, this is 0. Then it's going to be 4 minus 4x to the negative 2. So when I write this again, dy over dx equals negative 3 and minus 4 over x squared. Okay, so I've just done it both ways, and you're like, well, they're not even close to looking the same. But what you can do is substitute in. So I just want to show you something that right here, when I solved explicitly and isolated my y, I said y is equal to that. So this first one, when you're doing it implicitly, if you can look at it here, it shows that in the blue here is that I've got y's and x's mixed, which is what implicit differentiation is. And if you look at this one down here in the black, there's no y's at all. So I thought, well, to show that they kind of are the same, I'm going to take here what's in yellow and plug it right here in the y spot to see, are they really the same? So I have dy over dx. And in the y spot, I'm actually going to put negative, and I'm going to change all these signs. So it's a positive 3x because it's negative y. So I'm going to change all the signs, plus 2, all right, minus 4x to the negative 1. Okay, so I did that part. Then it says here, to subtract 2 minus 6x all over x. So all I did was in this y spot plug that yellow, and it just said to negate the y, so I changed all the signs, and then I put in the negative 2 minus 6x. So then we're just going to play around with it to see if I can get it to look like this down here. Okay, so I have dy over dx, and let's see what we got going here. Well, I see right off the bat that the 2's will cancel, so that's good to know. And I see that negative 6x and positive 3x, so I have minus 3x minus 4x to the negative 1, and then I'm going to divide them both by x because that's what it says to do. So let's do this again. So I got dy over dx is going to be negative 3 minus 4, and then if I have the same base and I subtract, that's going to be x to the negative 2. And if I were to rewrite that, lo and behold, it is going to match. So I have dy over dx equals negative 3 minus 4 over x squared. So I'm never going to ask you to do this type of thing here where I'm going to say make them look alike, especially if you have a choice. But it is kind of interesting to see where this is the derivative as well as this. It's just different methods of doing it. So that's number 1. All right, let's check and try another one. So the next one you have to do, because we're doing odds, is number 3. So let's do 3. And our problem is x cubed plus y cubed equals 1. So I look at it and say, oh, there's no product or anything going on. So let's go ahead and start doing the derivative. So I have 3x squared dx plus 3y squared dy. And the derivative of 1 is 0. I have all terms, so I'm going to divide through by dx. And then I know, thanks for playing, that divides to make a 1. So I'm going to leave the 3y squared dy dx here on the left, and I'm going to move over the the 3x squared, so it turns negative. Then I divide by the 3y squared because they're hooked by multiplication. So I have dy over dx. It's going to equal negative 3x squared over 3y squared. And when I do that, this cancel makes a 1. So it's negative x squared over y squared. So that's number 3. That was kind of fun. Wasn't that involved? All right, let's try 5. So when I do 5, I have x squared plus xy minus y squared equals 4. Now, when I do this one right here, this one doesn't look too bad, but I do have this going on here. I have a product rule going on here. So again, if I do f is x, f prime is going to be dx, g is y, g prime is going to be 1 dy, or we'll just call it dy. And then we're going to go through and do the derivative. So after a while, you kind of get used to doing this, but let's kind of go through this. So this is going to be 2x dx plus f prime g y dx plus f g prime x dy. So I've taken care of the product rule, minus 2y dy, and the derivative of 4 is 0. I have all terms, go through and divide through by dx. And when I do, I can say, thanks for playing, thanks for playing. There's a dy dx and there's a dy dx. So I'm going to save a step and say dy dx. I'm going to factor it out of these two, so I have x minus 2y. And then the rest of this, I'm going to move over on the other side, so I have a minus 2x minus y. And then on that, I'm going to go through and divide by the glop, or divide by the x minus 2y. So I have negative 2x minus y all over x minus 2y. And that's my derivative. Now, the other thing I wanted to show you, I actually looked in the back of the book on this and say, oh, how did they do on this? And their answer had every single sign was different. So it was a positive 2x, a positive y, a negative x, and a positive 2y. So if that happens to you and all the signs are different, then yours is just as correct as mine. It just means they divided by negative 1 or multiplied by negative 1 to change it. But other than that, it's the same thing. I think the last one I'm going to do on here is 7, so I don't make the video too long. So here's number 7. Okay, so I have x to the 4th. Got to see the problem here. X to the 4th times x plus y equals y squared times 3x minus y. And there's a couple ways you could do this. You could actually do product rule on both sides, or you can just multiply it through. You're still going to have to do the product rule, but I'm just going to multiply it through. But there's more than one way. You could do f and g's right here, but I'm going to multiply it through. So I have x to the 5th plus x to the 4th y. So there's a product right there. So I'm just going to see if it's saving me any time. Equals 3xy squared. There's another product rule, okay, minus y cubed. So I don't know if I'm going to save myself some time, but I just multiplied it through, and I'm going to have to do the product rule twice. So let's kind of set it up over here for the first one. I got x to the 4th for f. F prime is going to be 4x cubed dx. G is y. G prime is 1 dy. The other f is, I'm trying to see if I can fit it in here. F is 3x. F prime is 3 dx. G is y squared. I think I'm going to make it. G prime is 2y dy. Okay, so I've got my f and g set up over here to come over and start doing this. So let's go. So I got f prime g. So I have 4x cubed y dx. Okay, I always put the dx in the end, plus fg prime. So I have 4x to the 4th dy. Okay. Making sure I've got this right. So then plus, all right, so, oh, and I forgot. So I just did that one. I have 5x cubed here, so let's put that there, 5x to the 4th. So I actually should have done this first. So that's why I'm kind of slow here. I was looking at, what am I missing here? Equals, now we'll do the f prime g. I almost forgot this, so don't forget the first term. F prime g, so I got 3y squared dx plus fg prime. So I have 6xy dy. So far, so good. So now I'm going to go through, they're all terms, and divide through by dx. Dx. Forgot the dx here. Boy, it's 2 mistakes on that one. Sorry about that. Dx and dx. All right, so you can tell it threw me off when I'm trying to do a video. All right, so let's go through and say, all right, this term has a dx in it. So sometimes I actually have to do this. So this term has a dy dx, and so does this one. So I'm going to move those to the left and then everything over to the right. You could go the other way. It's okay. So I have dy over dx. So when I factor that out, okay, I'm going to have an x to the 4th, okay, and then I'm going to move over the minus 6xy, so I factored it out. On the other side, I'm going to have a 3y squared and a minus 5x to the 4th and a minus 4x cubed y. So I think I covered it all right? And then in order for me to do that, I want to divide each side by that. So did I hope I didn't miss anything. Was there another dy dx? Nope. So I'm just looking to make sure I did this right. All right, so now I'm going to divide through, so I have dy over dx equals 3y squared minus 5x to the 4th minus 4x cubed y all over x to the 4th minus 6xy. So that's what I should be getting here for my derivative. So I hope this helps, and I'll put another video for other ones.